Hello everyone, in this video we'll be looking at how to solve a system of equations using the elimination method. Now the main idea of the elimination method is to try and eliminate one of the variables so that we can find the value of the other one that's remaining. And after we find the value of that one remaining variable, we can simply plug it back into the equation to find the value of the variable that we eliminated earlier. The main idea or the main step here in eliminating one variable from the equation is adding both equations. And if you need a quick reminder on how to add two negative numbers, how to add two positive numbers, or how to add a positive and a negative number, you could check out my video on how to add and subtract rational numbers. So in this equation, we see that we have a positive 3 in the first equation, a positive 3x in the first equation, and a negative 3x in the first equation. So this problem has been set up perfectly for us, where we could simply add and we would have eliminated the x variable. So by adding this negative 3x to this positive 3x, we have eliminated x, so we no longer have to worry about it. Now we have a negative 4y and we're adding a positive 2y to it, and that leaves us with a negative 2y. We also have to add the numbers on the right side of the equal sign. So we have a negative 1, we add a 0 to it, and we have a negative 1. So we know that negative 2y is equal to negative 1. How do we find the value of y? Well, to get y by itself, we simply divide by a negative 2 to cancel out the negative 2 that's at the top. But if we divide by negative 2 on one side of the equal sign, we also have to divide by negative 2 on the other side of the equal sign. And that will leave us with y is equal to a negative 1 at the top and a negative 2 at the bottom. We make it a positive 1/2. Remember that two negatives will always cancel each other out. Now that we know that the value of y is 1/2, we can go ahead and plug this 1/2 into any one of these equations, and that will give us the value of x. Let's try plugging this into the second equation. So we have negative 3x plus 2, and instead of y, we're going to put 1/2. And that's equal to 0. We write the negative 3x again. We're not changing that. We are going to distribute the 2 to the 1/2. So 2 times 1/2 will give us 1. And that is equal to 0. Now to get the negative 3x by itself, because we want to find the value of x, so we have to get the x term by itself, we need to subtract 1 so that we can get rid of this positive 1. But if we subtract 1 from this side of the equal sign, we also have to subtract 1 from this side of the equal sign. And so what we have left is the 1's cancel, and we have negative 3x equal negative 1. Now there's one step remaining. To get the x by itself, we need to divide our negative 3x term by negative 3, so that the 3's cancel out and we're left with the x. However, if we divide one side of the equal sign by a negative 3, we also have to divide the other side of the equal sign by a negative 3. And what we have left here is x is equal to 1/3. Again, a negative number being divided by a negative number will always give you a positive number, and so your 1/3 is indeed positive. We could do a quick check, and it's always good to do a quick check to make sure that the value of y and the value of x works in our equations. So we're going to take the second equation, negative 3x, and in the place of x we will put 1/3 plus 2y, and in the place of y we put 1/2, and this should give us 0. I simply took this equation, negative 3x plus 2y equals 0, and I plugged in 1/3 for x, and I plugged in 1/2 for y. Negative times a positive, I know that my answer will be negative, so I put my negative sign for now. Negative 3 times negative 1/3, that will give us a negative 1. So that's negative 3 times positive 1/3. We put our plus sign back. Then we have 2 times a positive 1/2. 2 halves will give us 1. And that should be equal to 0. And we see that negative 1 plus positive 1 is indeed equal to 0. And so we know that the solutions that we find where x is equal to 1/3 and y is equal to 1/2 is indeed the solutions to our system of equations. Now this problem was set up nice and easy for us because the 3 was already positive, the 3x, and in the second equation the negative 3x was already negative, and so they canceled out quite easily for us. Let's try another system of equations where not everything was already set up so smooth for us, and we will have to then make the equation into what we need it to be. Let's try this one. 3x plus 2y, that should be, sorry. So that's going to be 3x. Let's make it 3y, and that's equal to 15. And then our second equation will be 2x plus 6y, and this will be equal to 22. Now we're going to solve this using the process of elimination. Which variable can we eliminate? Well, first of all, we can eliminate any variable that we choose. We just want to choose a variable that's the simplest for us. Not quite simple because both variables here, both x terms are positive, both y terms are positive. So what we will have to do is we need to make one of them negative. By making one of them negative, then we know that a negative and a positive can cancel. Likewise, on the x, a negative and a positive can cancel. Not only that, but the values have to be the same for them to cancel. So if this is a positive 6, I realize that if I had a negative 6 here, then the positive 6y and the negative 6y would cancel. So I now have to ask myself, how could I change this 3y, positive 3y, into a negative 6y? Well, if I could multiply by a negative 2, then I would get a negative 6y. But if I'm to multiply this term by a negative 2, I would have to make sure that each term in the equation gets multiplied by a negative 2 so that I do not change the value of the equation. So what I'll do is I'll put the entire equation into parentheses, and then I will multiply by a negative 2. That way I know that the negative 2 gets distributed to each term in the equation. So first I do negative 2 times positive 3x. That will give me negative 6x. While I did change the value of the x term, that's okay because we're not really focusing on the x term right now. We're trying to get the y term to be eliminated. I put my plus sign back. That does not change. Then I take the negative 2 and I distribute it to the positive 3y, and that becomes a negative 6y. Remember that a negative times a positive will always give you a negative. Now you could put your negative 6y in parentheses, or if you're comfortable with working with your signs, then you could go ahead and just take out that plus sign and replace it with the negative sign. Then our final step is to take the negative 2 and distribute it to that positive 15. Let's put our equal sign in. Negative 2 times a positive 15 will give us a negative 30. Remember, negative times positive will always give us a negative. And this is our new equation. This equation is equivalent to this equation on top. The only difference is this equation is twice as big because we multiplied by 2, and it's also negative because we multiplied by a negative sign. That's the only difference. But in terms of the left side of the equation, it's still the same. It's still in the same balance to the right side as this top equation is to the right side of that equation. So we didn't really change much with the equations. Now let's rewrite our second equation right underneath this first one that we just created. So I'm going to take this equation, 2x plus 6y equals 22. Now we see that we can go ahead and add these two equations now, because the positive 6y and the negative 6y will cancel, and then I'll only be left with the x term, and I could then find the value of x. So by adding these two equations, I add a positive 2x to a negative 6x, and I'll be left with a negative 4x. The positive 6y will cancel out with a negative 6y, and that gives me 0. You could leave the space empty, or you could put the 0 to remind yourself that the y term should be there, but we eliminated it. And this is equal to, we add a positive 22 to a negative 30. Now if you have trouble adding and subtracting positive and negative numbers, please check out my video on how to add and subtract rational numbers for a quick reminder. In this case, we have the positive 22, negative 30. That leaves us with a negative 8. And so we know that negative 4x is equal to negative 8. How do we get x by itself? Well, we could divide by a negative 4, so we can cancel out the 4's. But whatever we do to one side of the equal sign, we have to also do to the other side of the equal sign. So we also divide by a negative 4 over here. Now what we're left with is just the x, and the x is equal to negative 8 over negative 4. Now we know that a negative number divided by another negative number is going to be positive, so our answer should be positive. And 8 divided by 4 will be 2. And so now we found that x is 2. Now that we know x to be 2, we can choose one of our original equations. I'll choose the second one. And I can plug in the value of 2 in the place of x so that I can find y. So over here, I'll write 2, but instead of x, I'll write the 2 plus 6y is equal to 22. 2 times 2 is 4, so 4 plus 6y is equal to 22. To get the 6y by itself, I can subtract 4 from this side, which also means I have to subtract 4 from this side. Now some students, they get in the habit of saying, oh, we move the 4 over the equal sign and change the sign on it. Well, technically there is no mathematical logic that says we can move a 4 from one side of the equal sign to another side. What we do actually is we subtract that 4, but then we also subtract 4 from the other side, and that gave the appearance as if we moved this one and just put it on this side and change the sign of it. So what we have left is the 4's cancel, and we have 6y is equal to 22 minus 4. 22 minus 4 is a positive 18, and so 6y is equal to 18. From here, we divide by 6 so that we can get the y by itself. But if we divide one side of the equal sign by 6, we also have to divide the other side of the equal sign by 6. And what we have is y is equal to 18 divided by 6. A quick calculator or your multiplication table will show you that 18 divided by 6 is 3. And so now we have the value of y to be equal to 3. So now x is 2 and y is 3. And as I always say, it's always good to do a quick calculation by plugging both variables in to make sure that your equations work out the way we want them to work out. So let's try the first equation, and we're going to plug in the value of x and y into the first equation to see if we do indeed get the equation to be balanced. So we have 3x, but we know x is 2, plus 3y, but we know y is 3, and that should be equal to 15. 3 times 2 is 6, plus 3 times 3 is 9, equals 15, and we know that 6 plus 9 is indeed 15, so our equation works. Hopefully this was a lot of help for you guys, and don't forget to share, like, and subscribe if you found this video useful. Have a great day.